So my name is Jesse Samine. I'm a science content specialist out of ISU supporting the Illinois State Board of Education. Um, and this is ILELACOM, which I'm not used to hosting. I'm used to hosting the SciComm. But Jill Brown had a family emergency that she had to attend to, so she turned it over to me. Um, a few things before we get started. And I'm just reading this because I've never read this before, is that this is a recorded event. It'll be hosted to the platform. We will not distribute, sell, share, or share contacts to any other entities. No solicitation of any products or services are allowed on this. Online discussion is professional and courteous, please. The platform is provided to support each other's challenges and productive struggles with positive advice and resources. And our facilitators, Kathy just joined us, our facilitators, Jill and Kathy, can be contacted at those email addresses that are on the screen. I'm going to ask one more thing. If you're comfortable doing this, please turn on your video. So you can do that by finding the menu down at the bottom of your screen and clicking on Start Video. That's just helpful for me. Otherwise, I feel like I'm talking to a bunch of black boxes that have your name in it rather than actual people, so that's helpful. Another feature that you can find in that menu is the chat box. So if you click on the three dots that says More, there's a chat box there that we're going to use hopefully a couple times to go back and forth with some questions that we might have. At this point, I think most people are muted, and that's just to kind of reduce some of the background noise. But if you want to weigh in or you have a question, please feel free to interrupt, but you're going to have to unmute yourself to do that. Otherwise, we will not be able to hear you. So Jill asked for a picture of me, and I don't have pictures of just me. And so this is the best one that we have. So this is my 5-year-old daughter's, well, she's not 5 anymore, but this was her 5-year-old birthday, unicorn themed. So that's all of us. So like I said before, I am an ISB ISU science content specialist. I taught middle school science in Winnetka, which is a small district north of Chicago. Pretty high achieving, affluent area, and then spent some time as a science instructional coach in Elgin as well, for specializing in K through 12 science. I am also an Achieve peer review panelist for NGSS, which means that panel reviews lessons and units for alignment with the next generation science standards. Let's see if our chat boxes are working real quick. So if you could take a minute and in the chat box, go ahead and share your name and your location, what your position is, and feedback for me, how knowledgeable you are of the next generation science standards would be helpful before we kind of get moving here. So I'm going to give you a couple seconds to find that. So like I said, name, location, position or role in your district, and then knowledge of NGSS. So let's go knowledge of NGSS on a scale of 0, I don't know anything, to 5. I consider myself a content expert. Good. Great. So it looks like there's quite a few people kind of pretty familiar with the standards, which is good. and will kind of help our discussion a little bit. So when Jill asked me to speak, I said yes before I really knew what I was going to talk about. But I thought that the best use for this platform would be to address this question: is how can ELA and science teachers support each other to improve students' writing? She did ask me to talk about writing in science, and I know the science standards pretty well, and admittedly don't know the writing standards that well, and I think that's pretty common for science teachers especially, is that we know what's supposed to be going on in our classrooms, but could use some support from our ELA teachers in terms of, what are those commonalities between the two subjects, and how can we work together? It's a two-way street, work together to improve students' writing. So take a few seconds here before we start and actually think about that question. How can ELA and science teachers support each other to improve students' writing? So this is something that we do pretty commonly in science lessons, is that we kind of take our baseline, we want to know where we start, and then we'll readdress this question at the end. So take a few minutes. If you are a writer, go ahead and jot down some of your ideas. Maybe you have some examples of how this is done in your district already. And while you do that, I'm going to share a link of some resources that I've put together that I'll reference at a couple points during this presentation. So I'll share that in the chat box as you are thinking about that question. So I've shared those resources as a Google Doc in the chat box. So like I said, those will come up a couple of points during the presentation here. It's just nice to actually see the documents that I'm referencing, so that's why I shared those. So I thought, to get a good handle on this question, I thought that we should address three questions before we get there. And the first one being, what do our Illinois learning standards for science tell us about how students should learn science? And that has changed due to some research that's been done into how students learn science. And then with you guys thinking about, well, where does writing fit into those standards? And then also thinking about what writing skills do students need to develop in a science class. And it'd be helpful to see that through the lens of some of you ELA folks. So what do our Illinois learning standards for science tell us about how students should learn science? So this is what I used to do in my classroom, is that I had incoming 7th graders who had never had a formal science class before. And this is a pretty popular activity. I would ask them to draw a scientist. And this is a pretty typical response that I would get. As I would draw a guy with goggles, always goggles, lab coat, some glassware typically a white male. And then I would go on to explain that scientists also look like this, and scientists also look like this. But the commonality being that they all use the scientific method, that they're all making observations, then asking questions, then making a hypothesis, then designing an experiment, then doing analysis of that experiment and coming up with a conclusion. So I would tell kids that this is what all scientists have in common, and then I would say, and I'm going to teach you the scientific method so that you can be a scientist as well. So we would spend the beginning of the year talking about designing experiments and controlling variables and collecting data and doing those steps of the scientific method. And then I pretty much wouldn't use the scientific method after that. Like, that was it. That was our first unit. And then we'd go on to learn about cells, and I would tell them all the facts about the cells. And we wouldn't use this method very often, except for maybe the science fair, where I'd say they have to use it. So they and their parents typically would go ahead and use the scientific method. And I was never quite happy with that. And the reason being, I spent a lot of time as a scientist and working as a scientist in college. So I got to work with a lab out of Michigan State University studying the problem of sea lamprey, which are an invasive species in the Great Lakes. And we were trying to come up with ways to get rid of those sea lamprey, to get rid of them in the Great Lakes. And I knew there was a lot more that we did that wasn't being represented in that scientific method that I was teaching in class. So we were always trying to convince people to give us money to do our research. That was a big part of the job. We were building models for the impact of those different solutions in the ecosystem. We'd have to communicate with other scientists in our field, read their research and share our research. And I knew as a classroom teacher that those skills that we were doing as scientists weren't being represented in my teaching as in the scientific method. And then in 2012, a framework for K through 12 science education came out. And part of this framework shared some research into the work that scientists really do. And it was a lot more reflective of what I knew from my experience that scientists really do. It also shared that students should be mimicking that work that scientists do. So both groups, scientists and students, are trying to construct an understanding of the world around them. And because they're both trying to do that, they should follow the same practices. And so in that framework, it gave us our 8 science and engineering practices. So eight practices that scientists engage in and 8 practices that students should engage in to make sense of the world around them. So why don't you take a look at those 8 practices. And you may want to also refer to, on the document that I shared with you, there's a link to a document called Progressions of Science and Engineering Practices. So you may want to take a look at that as well. And share in the chat box, where do you see writing fitting into those 8 practices? Mm-hmm. And as we're spending some time thinking about this, I really do encourage you to pull up those progressions, because the progressions talk really specifically about what students should be doing at each grade level in those different practices. So some interesting responses, right? All 8, yeah, we're probably writing something in all 8. I think also some of the other responses kind of talk about this idea that the practices are so connected to each other that one flows into another, or one informs one, the others. And like I said, that progressions is pretty helpful in determining, especially as ELA people, determining exactly what students are doing in each one of those practices. Yeah, I like this comment. We are asking our staff to find ways in all 8 at different times to share purposes. So I'm hoping later, as we open up that discussion about that initial question about how we can support each other, to hear more about that. Mm. So this is a quote that stood out to me about writing from the framework itself. So it says, communicating in written or spoken form is another fundamental practice of science. It requires scientists to describe observations precisely, clarify their thinking, and justify their arguments. Because writing is one of the primary means of communicating in the scientific community, learning how to produce scientific texts is essential to developing an understanding of science, as learning how to draw is appreciating the skill of visual artists. So I think that speaks to a lot of the ideas that we saw represented in the chat box, is that writing is the communication that we use in all of those practices. And then this is another major shift in science education at this point, is the use of phenomenon in science instruction. So using phenomenon puts students in a place where they can engage in all 8 of those science and engineering practices, and puts them in the role of scientists. So our definition for phenomenon is: natural phenomenon are observable events that occur in the universe, and that we can use our science knowledge to explain or predict. The goal of building knowledge in science is to develop general ideas based on evidence that can explain and predict phenomenon. So this is something that we want our students to do, and it's something that scientists do. So here's a missed opportunity for me. So I used to teach an ecology unit. So we would talk about how ecosystems, the living parts, are connected to the non-living parts, and we would talk about the relationships between those living things. We would talk about how matter cycles in ecosystems and energy flows through it. And after we learned all of those concepts, I would use the reintroduction of wolves to Yellowstone National Park as an example of that. So in that article, it talked about how we had all this new vegetation growth along streams, which supported all kinds of different wildlife in the area because of the reintroduction of those wolves. So if I were going to use this as a phenomenon instead, I would put it at the beginning of my unit, and I would say, in 1996, wolves were reintroduced to Yellowstone National Park, and because of that, we saw all this new vegetation along the stream beds. And then I would allow students to ask questions about that. Well, what questions do you have? What questions do we need to answer so that we can figure out why that happened? So now all of a sudden they are in that role of a scientist. So now they have to engage in those 8 science and engineering practices so that they can figure out, that they can explain the connection between wolves and that vegetation along the riverbeds. Let's see if this works. So here's another example of something I used to do. So I used to do this thing called an ammonia fountain. So when I taught physical sciences, we talked about solubility of gases. We'd learn all about solubility of gases, when they're soluble in water. And then I would use this as a demonstration at the end. So I cut out the video, or I cut out the audio on purpose, because the guy gives away the answer. So he explains why that happens. And so what I would use, if I were to use this as phenomenon in my classroom, we would do that observation. And again, I would ask students, well, what questions do we need to answer in order to be able to explain that phenomenon? And then we're putting students in the position of scientists to be able to figure that out using the science and engineering practices, and then explain it also using the science and engineering practices. So I give you kind of all that background information just to give you an idea of, some of the shifts that are happening in science education now, and for you to think about, where does writing fit into that? So I want to talk specifically about these two practices, and I already saw connections to this in the chat box. So constructing explanations, designing solutions, and engaging in argument from evidence. So take a couple seconds to think about this question and go ahead and respond in the chat box if you would. So what science skills must students develop to be proficient in these practices? Again, if you want to go back to those learning progressions that I shared earlier, I would like to hear from you is what skills from writing do students need to develop in order to do that? So from your ELA perspective, what skills do they have to develop to do those two practices? Mm-hmm. Mm-hmm. Yeah, so I think we jump to that engaging in argument from evidence right away because it looks like very similar to our ELA practice. And give people a few more seconds to think about that. Maybe dig into those progressions a little bit more and see where your overlaps are. Mm, mhm, mhm. Yeah, so I'm seeing this idea of various sources, thinking about what that means in science versus ELA. Evidence in science also looks a little bit different. We'll show you an example of that here in a second. That counterclaims part is important too, because the reason that we engage in argumentation, the reason that we're using that practice is important and should be done in kind of a very specific way. Mm-hmm. Good. I'm looking forward to hearing an ELA perspective here. Um, so I'm going to walk you through an example of engaging in argument from evidence, and this is stolen, straight up stolen from the wonderofscience.com, which is Paul Anderson's website. But it's such a good example of this process of engaging in argument from evidence that I couldn't think of a better way to do it. So we're going to walk you through the same exact way. So at that website, which is shared in that Google Doc as well, thewonderofscience.com, you can find this organizational tool for argumentation. And of course, at the top, we have our question. So we're going to go ahead and give this a shot with you guys. And we're going to try to answer the question, how many bones and muscles are in your hand? Actually, I think we changed it. How many bones and muscles are in your hand system? So we're going to look at that as a system. And the first thing that I'm going to do with my students is that I want to make sure that we have a common understanding of the words that are in that question. So I'm going to give you our definition. So a bone is a hard object that support. Muscles are softer objects that move bones. A system is a group of interacting objects. So we have our question, we have our term. Oops, I skipped ahead. So what I want you to do is I want you to collect evidence now. And that's one of the, I think, downfalls of the claim evidence reasoning is CER, is that that's not the progression that we follow. So we want to make sure that we have our question clearly defined, and we can do that using the terms. And then we want to collect evidence. So we don't want to support that practice of making your claim first and then only finding the evidence that supports that claim. So I want you to go ahead and for a few seconds, take a look at this question. Take a look at your hand. This is why this is really great. Attendance is a great point. This is why this one's really great, because everybody brought these with them today. And think about evidence. So go ahead, move your hand. What evidence can you collect? And then this is where we go back to those terms, is when we talk about reasoning. So I can use because statements in my reasoning. So after I have collected my evidence, I should have a claim about how many bones and muscles are in the hand system. And then I can use my definitions. So those are the science ideas that we've learned. I could use those definitions as reasoning to support my claim, that connection between the evidence and the reasoning itself. So this will, I think, address some of those comments that came up earlier, is that there's some things that we want to make sure that we do when we're engaging in argument from evidence in science classes. So first is that it should be done in writing and verbally in science classrooms. So we talk about argumentation in writing for sure, but we also talk about argumentation, that idea of sharing evidence and making claims in class discourse and class discussions as well. So that practice is done in both modalities. A true argument, and now we're talking about, again, students, taking on the role of scientists, putting them in that position. A true argument is going to have more than one possible claim. So that's a little bit of a shift for a lot of science teachers. A lot of the labs that we've done historically have one explanation at the end. But allowing students to, collect that evidence and back up their claims from that evidence with each other is a more authentic way to do that in the direction that we want to go in. Arguments should be shared with peers, so whether it's verbally or in writing, it's a way that we make our thinking visible, a way that we share that. Again, an authentic practice that scientists use. And when we are sharing with peers, students should be given the opportunities to change their thinking based on the arguments of their peers. So going back to that argument and saying, my classmate had a good point. I didn't think of it that way. They had some evidence that I didn't. There was one more thing that I wanted to add to that, but I forgot. Oh, the difference between evidence in ELA and science is that we want to make sure that this is a Googleable question, right? Like you can look up the answer to this question, and that's confusing for some kids at this point. Is that we're using those terms, ELA teachers are using supporting with evidence in their classrooms, and that means evidence that they can find in text. That could be the case in science, but it's not always the case in science. So a lot of times we're talking about, observational evidence, whether it's quantitative or qualitative. So that's an important kind of distinction for some kids at this point. So one of the links that I shared in that document is about the difference between argumentation and explanations. So in that document that I shared, and I'll share it here again in case there are some other people who joined us, there's a document called "Is it important to distinguish between explanation and argumentation practices in the classroom?" And then there's also a document called "Explanation and Arguments, Same, Different, Doesn't Matter." So I'm going to give you some time to dig into those real quick. And when you have a response to this question, go ahead and share in the chat box. So what is the difference between constructing explanations and argumentations? So you might not see this explanations in ELA classrooms, but it's something that science teachers see. And it's a question that we see pretty often is what's the difference between those two? So again, go ahead and dig into those documents a little bit. When you have a response to that, go ahead and share in the chat box. I'm going to share this document link again for people who might have joined us recently. Mm. I'll give you guys a couple more minutes of digging here. So I will share something that kind of helps me keep these straight is that um, for me in a phenomenon-based unit, if I'm using phenomenon um, to drive that unit, students' questions, I'm going to use an explanation at the end of that, and it's going to explain that phenomenon. So it's taking evidence from lots of different sources, and it's explaining why whatever happened in that phenomenon actually happened. Whereas an argument might be used for a smaller piece of that. So maybe we did an experiment and we have to explain the results of that experiment. I have a whole bunch of evidence from that, and I'm going to construct an argument about how that happened. So I'm kind of using them at different points in a lesson. I think this is a great question for, if you're working with science departments, how those two things, how those two practices differ from each other and overlap with each other, and how they overlap across the content areas is a good question to kind of wrestle with. So going back to our original question, speaking of good questions to wrestle with, going back to our original question, how can ELA and science teachers support each other to improve students' writing? So I hope that I've given you some background about what student learning in science classes looks like and where writing fits into that. And I'm hoping that you can share with us and everybody about ways that those two content area teachers can support each other to improve students' writing. So I'd love to hear from you, but I'd love to actually hear from you. So if you could unmute yourself, I think everybody's muted at this point. If you can unmute yourself and share some ideas that you have about that question, or maybe ways that your district is already fostering this relationship between these two content areas, that would be great.
I'm thinking of one thought for especially students who don't feel very confident in their writing is that maybe seeing some models of what scientific writing looks like, and then identifying how they've either made an explanation or created an argument. And I think sometimes that can get kids more secure in being able to do that on their own when they see what that looks like.
Becky, it looks like you've unmuted yourself. Do you have something to share?
I'm thinking. I think just clarifying vocab in writing as well. We're going to use that word claim in science, and we're going to use an ELA, and they will overlap in several ways, but also being able to distinguish the difference for them, how that might differ in a science classroom in writing versus the ELA classroom in writing. Kind of what I'm wrestling with right now.
So maybe working with those two departments to think about some common understandings of what those are for the teachers and for the students, I think would be helpful.
I think it would just be even helpful for an ELA teacher to have a basic understanding of what we're talking about today. You know, they don't have to dig in deep, but just you know, understanding that what writing in one content area looks like won't necessarily be exactly the same in the other.
Mm-hmm.
And to understand the progressions in each.
Has anybody experienced models of support across these content areas that have been successful in the past?
I think Antioch District 34 for this school year, we have a teacher on special assignment called Atosa, and it's an ELA. She was the department chair, and she's working with all content areas in regards to writing. So we're answering that question this year.
Well, and I think since so many times students don't translate strong writing skills to other content areas outside of English. So something that they would do with great detail in English class, they might not think applies when writing in science. So just, again, you know, as much as showing students how the writing in the two classes might differ, also the common strands, right? That you're going to have evidence how that looks in one, you know, one class might be different than the other. But it really all is based in argumentative writing.
And I think part of that, from the science perspective, is making sure that students, you know, have an authentic purpose to engage in that writing. That, like that article says, they're trying to convince themselves and others that the evidence supports this claim, and that's a real practice. Like, it's something that they've really experienced, rather than kind of these. And I'm guilty. I have been guilty of it. These contrived premises about why it's important to construct these explanations or arguments.
I think one thought might be to make sure all teachers have the correct definitions for the terminology that we're referring to, and so they can talk in their classroom when they're talking claim or evidence. They can say, now this is similar to, and or an example of, but in science class you may do it this way, in social science you may do it this way, but make sure all the teachers have a common understanding of the terminology.
That's a really good point.
I think we make
Wouldn't it be great if you know, your school could develop a platform for that, some sort of resource for that, that would just be a nice reference chart, not only for staff members, but also students,
Or
you know, so they
chart.
see the connections.
An anchor chart that looks similar for literacy as writing as it does for science, so that they can make the connection that they are both doing the same thing.
And I think because the social science writing standards are the same as the science for technical subjects standards, then we're covering those major content areas with that support of that anchor chart. I think it's a great idea.
I have a job for my coach when I hang up.
There you go. And then to share it with this group.
I was just thinking, who's making a list of things that we need to have common understandings of?
Liz Janice is going to be working on it this week.
I think this is as good as a elementary teacher that I teach both the ELA and the science.
Right.
I know what to expect out of my students.
Sometimes I think it's almost easier for us elementary people than it is for our content area people at the middle school. That's why I threw that document up there. It's an old document, but it talks, there's a huge 6-8 section to it, and it's about content and science and literacy. Just because I think it's harder for our compadres over at the middle school to actually make the connection with the kids. They see them, if they get up and walk to another class, they see it as a very separate thing.
Mm-hmm. Mm-hmm.
Any other thoughts before we move on? I think a lot of people have a great action step already, right? It sounds like it's like, here, I need to check in with whoever's delivering science instruction about these, claim, evidence, argumentation, to make sure that we're delivering the same message to our kids. Any other final thoughts there? I did want to share that also at the bottom of that document, stuff that we didn't necessarily touch on, but there's some other great resources for argumentation, especially so the argumentation toolkit, argument-driven inquiry. So both of those have free resources for teachers to use to bring those lessons into their classrooms. Ambitious science teaching is great for not only argumentation, but all of those practices. And they do a really great job of showing you what those practices look like in the classroom. So make sure that you guys saw those as well. Kathy, do you want to talk about this since you're here?
Sure. Yeah, I was diving into one of the sites you just gave us.
Oh, I'm sorry.
Okay. Well, yeah, just because the argumentation piece, I noticed one of the quotes from the first source we looked at when we were looking at the difference between explanation and argument was a quote from Toulmin, Toulmin, I believe, and that is one of our go-tos for ELA for creating an argument using, similar graphic organizers that he's developed to write an argument. And I think because I happen to be looking at a standard for 6th through 8th grade for our writing standards for literacy and history, social studies, science, and technical subjects, which is a mouthful. Standard number 1 is all about writing arguments. Standard number 2 is all about writing explanatory or informational texts.
Mm-hmm.
Our standard number 1B is loaded with, I think, what you've referred to a lot, and I'll go ahead and read that. Support claim or claims with logical reasoning and relevant, accurate data and evidence that demonstrate an understanding of the topic or text using credible sources, which is a mouthful of things we're wanting a middle school student to do. And that's one of multiple standards. So I think what we said before about allowing students to have that common terminology used throughout all classrooms where we have agreed upon definitions, because I find one of the, I think, mistakes we're making many times is the kids hear definition of claim in one class and it sounds completely different from where they go second period, which sounds completely different than when they go to third period, and the same with evidence. And how we use all that may be differently, but I think sometimes we're our own worst enemy with confusing kids many times on the similarities with writing through the content area and how we need to all hopefully get on the same page with that.
Just to jump in here, there's one thing that stood out to me, and it was a while, I wanted you to finish, was that idea of credible sources, is evidence from credible sources. So in science class, we're teaching them that you are you're creating that evidence to be a credible source, whether it's in the experiments that you run or the observations that you make, that if you're doing science the way that science is done, then you're also a credible source that you can refer to. I remember that being a shift because our ELA teachers talking about using credible sources, and they were like, well, this is just an experiment that I did. And you're like, yeah, but we did, you did it correctly. Like, you did it for a reason. We're going to use that evidence as well. Sorry to interrupt.
Oh, no, I mean, yes, I remember too, it just pops in my mind every time I hear credible sources, is that, and then Debbie, I want you to share what link you put in there, but those fake websites that they create now for, like y'all know what I think about, the Tree Octopus. Have you seen that
Right.
one?
Yeah.
And the other websites that, because kids, all ages, high school included, and beyond, and adults, we click on something and we think it's credible. So I think another great point to make, since credible sources is all throughout all of our standards for social science as well. It is making sure kids have an understanding of how do you determine if a source is credible. We say credible sources, but do we give them any, like, look for the following things? Does science get into that at all?
Yeah, so that eighth practice of obtaining that middle part is evaluating, right? Evaluating information. So there's a whole, as I was putting this together, I was like, there's a lot of reading parts in there too. So digging through those practices and looking for those reading connections is really important. But that's also a great conversation to have cross-curricular about that evaluation part.
Mm-hmm. Yeah, it's what we want our kids to do, but we're sometimes remiss if we don't say this is how you determine if a source is credible, and give them some things to look for and question even. Debbie, what link did you send us?
It's
to?
just a silly one. It's it's just a claim evidence reasoning anchor chart. There's a whole bunch of them in here. One that I like that was probably pretty good that would go across all the ages for science and reading is the one that should pop up as the biggest one on your form when you take a look at it.
Mm-hmm. It does.
And of course, there's a million of them to the left.
That's great. And Janine, are you still on here? I don't know if Janine's still on here.
I am. I'm here. Sorry.
Okay. Well, isn't this one of your favorite strategies?
Yes, I love the claim evidence reasoning strategy, and I love the fact that it's applicable across content areas.
Yep.
So it's something that our students could see over and over and over again throughout the day, and not see it as just like an isolated tool that we use in science.
It's math, it's literacy, it's science, it's everywhere.
Yeah, but I think everybody has talked about how the important part is making sure that we're implementing it with fidelity, that we're really understanding what that means. I mean, Jesse pointed that out earlier, that this could be done wrong.
Mm-hmm.
We could really be we could undermine the intention if we're not very clear about the purpose and implementing it strategically and correctly.
Yeah. That's a great point. I think the anchor chart we talked about earlier, and then maybe the claim evidence reasoning chart, is some really great steps to look at for schools in trying to get people on the same page in the area of writing and constructing those arguments and explanatory texts. Okay, does anybody have any questions for Jesse? Because our time is about up. Jesse, your email address was
I think it's on
one of the slides.
I think so.
Okay.
If it's not, I'll add it.
Okay.
Chat box or something.
Excellent. Both Jesse and Janine work in the areas of science and are happy to answer your questions at any time. And I can't thank you enough, Jesse, because every time I hear something, I'm like, oh, I didn't realize that. Or reminded of those 8 practices and how a lot of those practices, even though they look different, are so important on building these lifelong learners and not just for a specific grade. Okay, well, once again, thank you all for attending, and we will have this posted on our site. So invite any of your colleagues to watch this, pose any questions to any of the content specialists, and also, if any of you create those anchor charts, we'd be so happy to see them, and then we can
Yeah.
share them with others. All right. Well, thanks so much. And thank you, Jesse.
Can I share the science information real quick? Oh, there is my
Please
email
do.
address. So yeah, so our work can be found at scienceteachersinaction.org. Free sources, which is a word that I think everybody should adopt this type of.
Oh, I love it.
And professional development opportunities. And then there's a way to join the listserv for information coming out on that, including, we do the IELTS ICOMs as well.
All right.
And there is my email address.
Perfect. Well, thank you all so much for attending, and thank you once again, Jesse. And we will talk to everyone soon. Bye-bye.
Thank you. Bye.
Thanks, bye.
Bye-bye.